Hello everyone, Mrs. Lindsay Pereira here. We're going to pick up after what you guys just did in class with your breakout rooms or in your groups. What am I? Problems number 1 through 4. We're going to continue on with points, lines, and planes. All right, so let's take a look here at our first example. And again, this is after the what am I. A plane, a surface such that if any 2 points on the surface are connected by a line, all points of a line are also on the surface. So a couple key things here. There are 2 dimensions, length and width, and they extend indefinitely. That's an important little concept. Even though when we draw it, it looks like it has boundaries to it, it does not. It extends indefinitely in both directions. And there's no thickness to it. So again, you might hold up a piece of paper and say that represents a plane. Physically, yeah, we're looking at that and we say those types of things, but that is a 3-dimensional object. It is rather difficult to draw. We typically draw it so it looks like a parallelogram, okay? And again, it's not ending at these boundaries that I just drew here. It goes on indefinitely in all directions, okay? So let's talk about a plane just a little bit more. So I'm going to add a little bit detail to this diagram. So I'm going to draw, again, a few different things on here. So go ahead and take a moment, draw these on here. So I've got points along here on these lines. Again, we don't always highlight them, but that's what I'm representing there. Okay, so how do we name a plane? You can name a plane by using the lowercase italic letter that's kind of typically and usually in one of the corners. And again, it doesn't look very italic, but it's supposed to be. Sorry, I don't write that very well. Or we can also use 3 non-collinear points. So for example, I could call this plane A, B, E. That kind of leads us to what forms a plane. And if you notice, I said 3 non-collinear points. This is what forms a plane. So there's 2 options. That's the first one. Non-collinear. So let's look at the root word. Sorry. So we have linear or line here. They cannot all lie on the same line. So for example, I could not name this plane ABC because I would also have, if you can visually think about this, I would also have a plane going vertically through ABC. There's actually an infinite amount of planes that go through there. So we could not name that plane by collinear. They must be non-collinear. Okay. And the other way to define a plane is by 2 intersecting lines. Okay, so we have line AC and we have line DE. That forms our plane there. Okay. And those actually lie within inside that plane. Nothing is going outside of this plane, which again we kind of represent with a parallelogram. And again, they extend both indefinitely in all directions here. Okay. Right, so here's what I'm referring to, non-collinear and collinear. So just kind of going over this again. Collinear points are points that lie on the same line. So in our diagram here, so examples A, B, and C are collinear, okay? Non-collinear is opposite, obviously, of collinear, points that do not lie on the same line. So points A, B, and H are non-collinear, okay? So before we move on, though, question for you. Are points B and H collinear? Think about that just a moment. Obviously, the answer is really yes or no. A lot of people here might say no, but the actual answer is yes. Definition of a line, it takes 2 points to form a line. I have only 2 points here. So anytime I'm ever given 2 points, they are always collinear. It doesn't matter that there's no line here. I know there's no line drawn there. I'm going to erase that. There's no line drawn there. That's okay. They are still collinear though. Okay. And you always have to look at them as a group. Okay. You can't say, well, so if I said, for example, our points A, B, and H collinear. That does not look, let me erase that there. And the answer to this one is no. You can't just say, well, A and B are, or A and H are. You can't, they're all on the same line, or they are all not on the same line. So again, you have to look at them as a group. Okay. All right, so we actually have a few more definitions here as well. Coplanar, so very similar to collinear, but now we're talking about a plane. Again, looking at the root word there. Planes, lines, segments, and so forth that lie in the same plane. So obviously the opposite of that is non-coplanar. Points, lines, segments, and etc. that do not lie in the same plane. So notice this goes past just points, and it can include lines, rays, segments, all those types of things. Unlike collinear, you're only referring to points. Okay, so a couple more, and then we'll go over some examples with this. A line intersects a plane not containing it, then the intersection is exactly 1 point. If a line intersects a plane, so here's a plane, and think about that being a piece of paper, and then I just put my pencil through it. So I would have something that looks like this, dot, 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 and then extends down through the bottom. It hits at exactly 1 point. Okay. The next one says, if two planes intersect, then their intersection is exactly a line. Now this one's a little bit challenging to draw. So let me go ahead and draw this one here. And then let me draw another one. So think about like two pieces of paper, for example, connecting there. So this would be dot, 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 dot. And then this comes up above that. So they would intersect at this. I did not draw that very well, but that's what that would look like. So they would intersect at this line. And again, remember, planes extend indefinitely in both directions. I should have made this dotted. So it looks like it actually goes through it. Okay. So again, think about two pieces of paper intersecting. Where would they intersect? At one single line. Okay, so let's actually try some examples here. It's actually a much better diagram of two planes intersecting, by the way. So you can see you have plane N here, that's kind of more vertical, and then plane M, which is more horizontal, so they only intersect at a line there. Okay. Okay, so that actually brings us to A, plane M intersecting plane N. So what we just talked about there, that would be this line that goes on forever in both directions. So again, it's not a segment, it would be a line. So make sure, again, you have to be very specific. If you just wrote AB for your answer here, that would be incorrect. You need to say, put your symbols above it. Is it a line? Is it a ray? Is it a segment? Be very specific. Again, geometry is very symbolic. Okay. All right. So now what about B? A, B, and V determine what plane. So let me go ahead and just erase this red portion right here. So we have A, B, and V. So we have A, B, and V. So they are all on this horizontal. Now, I don't necessarily know that, it just looks like it. They're all on this plane. So they define plane M. Okay. All right, so name 3 points that are collinear. They have to lie on the same line. Okay. So actually the ones we just highlighted would not work. There are probably a few different answers here. But one set of them would be, for example, I could do V, P, and W. But again, there's more than one answer for this. So hopefully you see here, you could also do R, P, and S. That would be another set of answers. And even A, P, and B. Okay. All right, lines AB and RS determine what plane. So AB and RS. Okay, so again, intersecting, that has to be going up and down, so that's going to be plane N. And again, let me erase this. Okay. AB and point what determine plane N. So let me highlight this. And notice how I'm doing this over and over again. I'm highlighting things, I'm circling things. It's going to be extremely important as we start going through our homework, your book work, that you draw pictures, you write on your diagram. A lot of your work will be on your diagram. So you have AB and point what determine N. Well, that would be R. Or you could actually say S. Okay. All right, so we have another example here. I actually would like you to pause the video on this one and answer these, and then push play when you have answered them, and we can go through your answers. Okay, so does W lie in plane N? And no, it does not. So that's what they try to represent with these dotted lines over here, that it doesn't actually, like you're looking through this plane. So it actually lies in plane M. Okay. Line AB and VW, so AB and VW, intersecting lines, determine plane M. A, B, V, and W are coplanar. You could have also done P here. That would have worked as well for H. I, so now we have A, B, V, and S are non-coplanar. So again, S is one option. You could have also done R there as well. And then J, if R and S lie in plane N, what can be said about line RS? That it also lies in plane N. Okay. All right. Okay, and let's go to our next example here. So sorry, I don't know why my dog just kind of yelped, but that was my dog. Okay, let's look at a jack. All right, so we have a jack, and you can kind of see here I have a few different diagrams of it, but over here to the right, I actually have some lines that represent the jack. Okay, so every single jack really has those three intersecting lines. Okay. So what I've done is redrawn it down here. And it says name 3 different planes that contain E. Okay, so we have plane A, E, D. And that's really kind of representing this plane that goes right through here. So it'd be kind of this little parallelogram. Again, we don't really show it, but ADE, so it's kind of more that horizontal one. Then we have plane AFD, and this is more of your vertical one. So again, we're looking here kind of AFD, and then it kind of keeps coming down here through C, so it's more of the vertical one. But there's actually a few others, okay? It's got to go through point E, okay? So we could think about EFD. That would be another one. So that is, let me write this down first. That's more of a slanted plane that goes this direction. Okay? So this way. Okay, and there's several other ones. So you could do EDC, that would be another one as well. Again, there's ones that are slanted. That's what you got to think about in that case. Okay, so there's other answers that you could put for A. All right, and then in B, name 2 different planes that contain the line, or sorry, I apologize, ray AD. So 2 different planes that contain ray AD. So we have a couple of them up here. So we have plane, I'll do ACD, which is the exact same thing as plane AFD. And then one other example here, would be, we could do the horizontal one again if we would like, and I will do a different one. So A, B, D, different letters, but it's the same as plain AED. Okay, so this wraps up our notes for the first section, first day of geometry, section 1-1.